Okay, so we're going to prove that if a and b are odd integers, then 8 divides a squared minus b squared. So let's go ahead and start this proof. We're going to have a and b be of the form, so we'll have let a be equal to 4k plus r sub 1, where r sub 1 is bigger than or equal to 0, and it's less than 4. Okay, and b be equal to 4q plus r sub 2, where r sub 2 is bigger than or equal to 0 and less than 4. And of course, k and q are integers, right? Where k and q are integers. All right, so now what we're going to do is, since we know that a and b are odd integers, we only have to focus on when a is 4k plus 1. So r sub 1 is 1, b is 4q plus 1, a is 4k plus 3, and b is 4q plus 3, right? Those are all the odd integers if we look at the numbers in the form 4 times some integer plus the remainder, right? All right, so we're going to develop a few cases. So the first case, we're going to have where a is equal to 4k plus 1 and b is equal to 4q plus 1. All right, so this means that a squared minus b squared is equal to 4k plus 1 squared minus 4q plus 1 squared. And that is equal to, so that'll be 16k squared plus 8k plus 1 minus 16q squared plus 8q plus 1, right? And then this will just be 16k squared plus 8k. And this will be positive 1 and this will be negative 1. So the 1s will just go away. And then we'll have minus 16q squared and then minus 8q. And of course, we can definitely take out an 8 from this, right? This will be 2k squared plus k minus 2q squared minus q. And then we have that this is an integer. So we have a squared minus b squared is equal to a times an integer. So at least when a and b are of the form 4 times an integer plus 1, we know that 8 divides it, right? 8 divides a squared minus b squared. All right, so now the second case, so let's go ahead and go to case 2. We'll have it where both of them are in the form 4 times. So a is equal to 4 times an integer plus 3, and b is equal to 4 times an integer plus 3, right? So this implies that a squared minus b squared is equal to 4k plus 3 squared minus 4q plus 3 squared. And this will be, so 16k squared plus 24k, right? Yeah, 24k plus 9 minus 16q squared plus 24q plus 9. And just like with the last one, you can see the 9s are going to cancel and you're going to be left with 16k squared plus 24k minus 16q squared minus 24q. And then, of course, let me go ahead and go to this next line. We can take an 8 out of this, right? So this will be 2k squared plus 3k minus 2q squared minus 3q. And of course, this is an integer. So we have a squared minus b squared is equal to 8 times an integer. So this means that 8 divides a squared minus b squared when we have a and b being of the form 4 times an integer plus 3, right? Now we have to think of the case where one is 4k plus 1 and the other is 4 times an integer plus 1 and the other one is 4 times an integer plus 3, right? So case number 3, we'll have it where a is equal to 4k plus 1 and b is equal to 4q plus 3, right? So this means that a squared minus b squared is equal to 4k plus 1 squared minus 4q plus 3 squared. And then this will turn out to be 16k squared plus 8k plus 1 minus, and then this will be 16q squared plus 24q plus 9, right? And as you can see, this will turn out to be 16k squared plus 8k. So it'll be positive 1 and negative 9, so it'll be negative 8. So I'll just do that at the end. So minus 16q squared minus 24q, and then minus 8, right? And of course, we can take out an 8 out of all of these, right? So this is equal to 8 times 2k squared plus k minus 2q squared minus 3q minus 1. And then this is a squared minus b squared is equal to 8 times an integer, right? So this means 8 divides a squared minus b squared. And then it's the same reasoning with case number 4. I'll go ahead and do it, but it's going to turn out to be the same thing. So case number 4, that is when a is 4 times an integer plus 3, and b is 4 times an integer plus 1, right? So this would be when a is equal to 4 times an integer plus 3, and b is equal to 4 times an integer plus 1, right? So this means that a squared minus b squared is equal to 4k plus 3 squared minus 4q plus 1 squared. And then this will just be 16k squared plus 24k plus 9 minus 16q squared plus 8q plus 1. I need to put that parenthesis around there, right? And then here, and here, right? And then this will be equal to, so this will be 16k squared plus 24k. And then 9 minus 1, so that'll just be plus 8 at the end. So minus 16q squared minus 8q plus 8. And then, of course, I could factor out an 8 from this. So this will be 8 times 2k squared plus 3k minus 2q squared minus q plus 1. And then, of course, we have a squared. Let me go up here a little. A squared minus b squared is equal to 8 times an integer. So this means 8 divides a squared minus b squared. In all cases, right? In all cases where a and b are odd. And that's what we set out to do. That is the proof.